Welcome to Mission Evolution Radio Show with Gwilda Wiyaka, bringing together today's leading experts to uncover ever-deepening spiritual truths and the latest scientific developments in support of the evolution of humankind. For more information on Mission Evolution Radio with Gwilda Wiyaka, visit www.missionevolution.org. And now, here's the host of Mission Evolution, Miss Gwilda Wiyaka.
Hello, my visionary friends. Thank you for joining us on another exciting adventure into future possibilities. This is Mission Evolution, where we share innovative thoughts and information with today's leading experts, bringing evolutionary solutions to today's unique challenges. You, my treasured audience, are a very important part of this discussion. Email info@missionevolution.org with any comments or questions. We'll address them on the very next show. So take notes, sit back, and enjoy as we enter the land of co-creation. This hour will consider COVID-19 drug repurposing. Fall is upon us, and with it the threat of the second wave of COVID-19. At the same time, restrictions are loosening and many children are returning to school, increasing the risk of exposure to the pandemic. While the mad scramble for a viable vaccine continues and reports of reinfection rise, for the time being, immunity seems out of reach. What if, God forbid, we or our children come down with COVID-19? What are the options for treatment? Given a brand new COVID-19 cure is still unavailable, where can we turn for help? Are there existing viable options that we may be overlooking? With us this hour to explore the possibility of repurposing drugs to treat COVID-19 is Dr. David Fajgenbaum. Dr. Fajgenbaum is a groundbreaking physician, scientist, disease hunter, speaker, and best-selling author of the memoir, Chasing My Cure, A Doctor's Race to Turn Hope into Action. Labeled the doctor who cured himself by New York Times, Fajgenbaum went from being a college quarterback to receiving his last rites while in medical school. He died nearly 4 more times battling Castleman's disease, a deadly cytokine storm disorder. To try to save his own life, he spearheaded an innovative approach to research through the Castleman Disease Collaborative Network, discovering a treatment that has put him into the longest remission ever. This approach is saving his life and others as well. Now he's spearheading the same approach to other diseases like COVID-19. His website, chasingmycure.com. Dr. Fajgenbaum, on behalf of my listeners and myself, thanks so much for joining us on Mission Evolution.
Gwilda, thank you so much for having me.
Where did you go to medical school?
I went to the University of Pennsylvania.
And what was your specialty at that time?
So I initially decided I wanted to go to medical school. While I was in college during my sophomore year, my mom passed away from brain cancer. And that experience of watching her diagnosis, watching her valiant fight against cancer, and watching the impact her doctors had on her life and all of our lives, I knew that I had to go into medicine. And so I decided from the time I was about 19 years old that I wanted to become a doctor, and I was really laser focused on wanting to become a clinical oncologist. I wanted to treat cancer patients like my mom. And then just as you shared, out of nowhere, I went from being this medical student training to be a doctor to all of a sudden becoming the patient, and everything changed.
I understand you went from being a quarterback in medical school to nearly dying 5 times. Would you mind sharing that with us?
Sure. Yeah, I was a quarterback at Georgetown. So in undergrad, my lifelong dream before I got to college was to play college football, and I was fortunate enough to be recruited at Georgetown, where I played there. And many of your listeners may not realize that Georgetown has a football team. We're not known for our football. We do have a team. We don't win very many games, but it really was a lifelong dream for me to be able to play college football. And it was when I was at Georgetown in college that my mom became sick with cancer, and that my lifelong dream of becoming a college quarterback changed to now becoming my lifelong dream of wanting to take on cancer.
It's so difficult to lose a parent at that age. It just, my condolences. That's a tough thing to get through.
Well, thank you. It really is such a tough time because, you're just away from home for the first time. You're away at college. It is a tough time. And actually, I started an organization in memory of my mom called AMF. Those were my mom's initials, and it also stood for Actively Moving Forward. And it still exists today, supporting college students grieving the illness or death of a loved one.
Oh, that's a beautiful way to process, isn't it? To serve others.
It is.
Yeah. So I understand you came down with Castleman's disease. What is that?
Castleman's is a rare immune system disorder. We don't even know whether to call it a cancer or an autoimmune condition because it's got features of both. But basically, out of nowhere, my immune system just turned on and started attacking all of my vital organs. Your immune system is supposed to protect you, but unfortunately, sometimes it can turn on for unclear reasons and then cause lots and lots of harm. I experienced what's called a cytokine storm, which is basically your immune system going in overdrive. And in doing so, I became so ill that, as you mentioned during the introduction, that I had my last rites read to me because the doctors didn't think I would survive. My liver, my kidneys, my bone marrow, my heart, and my lungs were all shutting down. And thankfully, I survived. I got a lot of chemotherapy that saved my life. But unfortunately, I would go on to have relapse after relapse after relapse.
What is it like to experience a cytokine storm from the perspective of a patient?
So I think there are a number of feelings. One is of fear. It's terrifying to basically have all of your organs begin to shut down because of something that's supposed to be good, your immune system actually causing harm. So it's really terrifying. It's also really, really painful when your liver and your kidneys and your bone marrow and your heart and your lungs, when they all shut down, you experience extreme pain because the lining around your vital organs begin to stretch, and it stretches so much that it just causes almost like knife-like pain all over your body, and it's also really tiring. So you can think about when you've had the worst flu or cold, or hopefully you've never had COVID, but if you've had one of those infections, you would know kind of the fatigue that comes with having a cold or a flu. Well, a cytokine storm is like 1,000 times the fatigue that you would have from a cold or the flu, and it's where you just feel awful. The term cytokine storm has actually been used a lot more recently. I run a center focused on studying cytokine storms, and something we've been studying for a while. But in light of COVID, it's become clear that a number of the most severe COVID-19 patients will experience one of these so-called cytokine storms.
Yeah, I want to ask you about that because I've heard from various scientists and medical doctors in the process of doing this special that I'm doing on COVID-19 that it's not the COVID-19 that ultimately kills the patient. It's the patient's own body turning on themselves, which is a cytokine storm, right?
That's exactly right. When we think about when you get infected with something, whether it's a virus or something else, we think about your immune system as being that protective defense, and its job is to fight off whatever has infected you. And that's exactly right. That is the job of the immune system. But unfortunately, if you have a little bit too strong of an immune response, or even a little bit of too weak of an immune response, then things can go haywire. And so you almost want to have that like perfect response where like the immune system fights the virus with the perfect amount of might and the perfect amount of energy, and it puts this virus away. But if the virus causes the immune system to spiral out of control, then that's when you can have, as you said, the cytokine storm that actually is what kills the most severe COVID patients. It's not the virus itself that kills the most severe patients. Is actually the body's response in trying to kill the virus. The immune system causes all this collateral damage.
And it's inflammation related. Most of us actually in this day and age have overactive inflammation in our bodies, don't we, because of our diet and this and that.
There's a lot of factors. You're absolutely right that contribute to kind of our baseline state of inflammation. The immune system is supposed to be turned off 99% of the time. It's really only supposed to turn on when there's a virus to fight off or bacteria to fight off. That's, it should be in a quiescent state or a kind of a state of sleep until it needs to be turned on. But you're right. There are things like diet and environmental exposures that can cause it to kind of be in like a low grade kind of a smoldering state state instead of being turned off. And you can imagine that being in a smoldering kind of low-grade state all the time, that can cause problems because the immune system really isn't supposed to be turned on and causing inflammation. And it's something that, I've learned a lot about because, as I shared, experiencing the cytokine storm and then eventually identifying a drug that could target my cytokine storm and save my life is why I'm here today. I get to talk to you today because of a drug that I discovered that could actually target the cytokine storm and save my life.
And once again, true to form, you're now turning that experience around to help others.
I certainly am trying to. When the pandemic really first began to hit the States, you'll probably remember Friday, March 13th. That Friday the 13th was the day that the country started to shut down when it became clear that COVID was going to be a serious problem. And I found myself, I was in my car. Excuse me, I found myself thinking and hoping that some researchers somewhere would follow our approach to research, would follow the path of chasing my cure and do the same things we did for Castleman's for COVID. And then about 30 seconds later, I was like, wait a minute, why are you waiting and hoping for someone somewhere to follow your approach? This is what we've been doing for the last 10 years. We should do it. And so I reached out to my team and basically the bottom line is that we all agreed that we were going to do this. And so we've really been following the playbook. You mentioned earlier my book, Chasing My Cure. That's almost in a way a playbook for how do you take down a disease? How do you chase a cure? How do you save lives? And we've really been following that playbook for COVID ever since.
Well, that certainly gives us hope where there isn't a whole bunch of hope out there for a short-term solution. What makes a person more predisposed to experiencing the cytokine storm if they indeed come down with COVID-19 or anything else like that?
The jury's still out on all of the factors that contribute to this, but it looks like right now there's a combination of if you have a comorbidity like diabetes or hypertension, that certainly puts you at risk of having one of these cytokine storms if you get infected with COVID. There are other genetic factors that have become clear. There are certain genetic sequences or changes that may actually make you more or less likely to have a cytokine storm from COVID-19. We're still really trying to tease it all apart because what would be great is if we could test for these things in healthy people who are not yet infected with COVID and get a really good sense for, okay, you're really likely to have a very bad COVID infection, or you're really likely to have a mild COVID infection. That could really help us with getting back to life and getting back to, where we all want to be as a society. If you could really, with high accuracy, feel confident based on someone's genetic makeup or based on their comorbidities, whether they're going to have a poor or strong response. And that still hasn't been done, but I think it's something that many of us are working on.
Well, I think that's one of the most amazing things about COVID is the wide variety of responses to the disease, from not even knowing you have it to death.
Absolutely right. And as of right now, it's kind of feels like a slot machine or a lottery as to whether you're going to have a good or a bad response. You don't know what to expect. It feels like you're just playing the odds. But that's where we really need to get down to exactly what genetic changes, exactly what environmental factors, what comorbidities that you have that really make you likely to have a really good or really bad response to COVID. And many of us, like I said, are working on it, but unfortunately, we don't have a very clear algorithm yet. We are getting better and better at understanding when someone shows up to the hospital. There are a number of blood tests. One in particular is called interleukin 6. That if you measure measure that level right when they come into the hospital, you can predict pretty well whether they're likely to have a really bad hospital stay and potentially die versus a much more mild hospital stay. IL-6, this interleukin 6, is a really good marker of it, and that was actually one of the reasons that I decided wholeheartedly to dive into studying COVID. I mentioned I run this Center for Cytokine Storm Treatment and Laboratory, but it really was learning that interleukin 6 was very important. That particular protein, interleukin 6, is actually the most important cytokine in Castleman disease. And actually, there are drugs that were developed for Castleman disease that target interleukin 6 that have actually now been used in COVID-19, which I think is an important lesson.
We're going to have to get more into that particular treatment on the other side of a commercial break, because we are at the end of this segment. But Dr. Fajgenbaum and I will return shortly, so don't you go away. You're listening to Mission Evolution, coming to you on the X-Zone Broadcast Network, www.xzbn.net. You stay right there. We'll be back. Hello again. This is Mission Evolution, missionevolution.org, dedicated to unification and evolution of consciousness. To all our faithful and thoughtful listeners, we really value your opinion and would love to hear from you. What do you think about repurposing drugs to fight COVID-19? This in from a member of our audience regarding the episode entitled Supporting Children Through COVID-19. LR comments, I found this episode very helpful, but I'm still really concerned about the impact the pandemic will have on our children long term. I was wondering if you could get some more guests on the topic. Thanks, LR. We'll see who else has some helpful information on this very important topic and have them on the show as soon as possible. Curious, dear audience? Visit our archives at missionevolution.org, listen to the episode entitled Supporting Children Through COVID-19, and let us know what you think. Email me at info@missionevolution.org and give me your thoughts or questions so we can all share them on the next show. With us this hour discussing repurposing drugs is Dr. David Fajgenbaum. His website, chasingmycure.com. We were just getting into a test, David, that you can do at the hospital that'll give a pretty good marker as to where a person stands with the disease. Would you continue with that, please?
Sure, absolutely. So this particular test is called interleukin 6, and interleukin 6 is a cytokine. So we've talked about cytokines a few times so far today, but I didn't really get into what they are. So cytokines are proteins or molecules that your immune system produces in an effort to fight off an infection. Those same molecules, these cytokines, also help the immune system to communicate with one another. And so interleukin 6 is one of the most important cytokines in fighting off infections. And it's actually really, really elevated in Castleman disease. And so this same test that you can do when someone shows up to the hospital with COVID that will tell you if someone is likely to have a very good or a very poor outcome from their COVID, the same test also is used in Castleman disease because there are drugs that target interleukin 6 in Castleman's. There are actually 2 drugs that are FDA approved that were developed for Castleman's over the last couple of decades. And I think it's an important lesson that a lot of times people say, okay, this disease is rare. It affects 5,000 people in the US per year. I'm not going to focus my effort on it, but this is a great example where drugs developed for this very rare condition, Castleman disease, actually are now being used in COVID and a number of other conditions like rheumatoid arthritis and even as part of cancer treatments. And so this is an important lesson, and I can't talk about interleukin 6 without mentioning my good friend and colleague, Kazu Yoshizaki, who actually discovered that interleukin 6 was elevated in Castleman's, and he went on to develop the drug to target it. And I'd heard a rumor that he had tested it on himself. He'd given it to himself to prove that it was safe before he gave it to other humans. And when I asked Kazu, I said, Kazu, I heard you gave it to yourself. He said, no, I didn't give it to myself. The nurse, she gave it to me. So this amazing researcher, he developed this drug. He tested it on himself. He didn't die, so he gave it to a bunch of other people, and it went on to get approval. And I think I just love that story so much. And that certainly was a story and an experience that informed me and inspired me as I was on my own journey chasing my cure.
Is anxiety, anxiety is an interesting thing, but isn't anxiety also involved in inflammation? But which comes first, the inflammation or the anxiety?
That's a good question. And I think you're right. There's no doubt that psychological state, environment that we're in, that those can all contribute to our immune response. We were chatting earlier about how your immune system is really supposed to be in a quiet or quiescent mode until it has to turn on. But sometimes things, environmental triggers, psychological triggers, can cause it to go into kind of a low grade situation where it's kind of in the on position when you want your immune system generally turned off until it needs to be turned on. So yeah, there are a lot of factors, and unfortunately, there's a lot still to be learned about the immune system. It's I think in my opinion, it's the most fascinating system of the body, but it's also undoubtedly one of the most complicated organ systems.
I think we're really starting to recognize how everything is connected to everything else. We used to kind of compartmentalize it. Oh, well, the immune system is
Yep.
here, and and the cardiovascular is there.
Yep.
But now they're saying, well, your heart has intelligence and your
Yep.
gut has intelligence. It's really, I love to see this opening up, because don't you believe that the process of opening up this interrelatedness will crack the shell on a lot of things we've been unable to cure?
I totally agree with that. I think that interrelatedness is the reason that I think so little has been done in the past into this is that scientists like myself, we study specific diseases or cell types or pathways within given disease areas, and we really get very focused, and that's how we make breakthroughs. But sometimes getting so focused can create silos, and I think that you're absolutely right that as a medical community, we're really starting to open up those blinders and look at the related conditions and the overlapping conditions. And boy, is COVID a great catalyst for that, because I mean, COVID is a great example where it seems to affect anything and everything in your body. And I think that this is just COVID has been terrible in every possible way. But I do think that there are some silver linings from COVID, and that I think that, to your point, they're helping to expose that maybe we shouldn't think about diseases as just being a lung disorder or just a heart disorder, like you said, but really recognize that diseases, affect many systems, and that all these systems are interconnected. But also, I've been so impressed by the amount of data sharing that's been happening within the medical community. Data is being shared freely. People are collaborating in ways that I've never seen before. And there's a real interest in drug repurposing, which you mentioned a couple of times so far. And drug repurposing is the concept that you take a drug approved for one condition and then you try it for another condition that it's not approved for. And I'm literally alive today because I did that. I took a drug approved for kidney transplantation and I tried it for Castleman disease, and it's saving my life. And being someone who's benefiting from drug repurposing and literally talking to you today because of it, I've really felt this obligation to do everything I can to look for other drugs that are already out there that could be used in new ways to save patients' lives.
Well, the kidney transplant drug, wasn't that to prevent rejection, which is kind of calming down the immune system?
You're exactly right, Wilda. Yes, so exactly. So that kidney transplant drug called sirolimus, it inhibits the immune system and inhibits a couple parts of the immune system in particular really, really well. And so in Castleman disease, I did a series of experiments and understood in the lab that a few aspects of my immune system seem to be in overdrive. And thankfully, this drug actually targets those three aspects of the immune system really well. And so it went from, okay, this is what's going on in my immune system. What drugs are already out there that can actually suppress or inhibit these things in my immune system, even if no one's ever tried it for Castleman's, because no one had ever tried sirolimus for my disease. But that didn't mean that it wasn't going to work. But it also didn't mean that it was going to work, based on the data we needed to actually try it.
So would you go into a little bit further the new approach of repurposing drugs? How do you narrow down which ones were the ones that be a candidate for it?
Sure. So there are three parallel paths you can take in drug repurposing, and I'm a big proponent of doing all three. I think in medicine and in life, people like to find, one way and say this is the best way to do it. But in science, I'm actually a big proponent of taking multiple approaches and then understanding the limitations of each of them and trying to find, what's truth. And so the three approaches: one is that you can take cells from a patient, let's say it's with COVID or with Castleman disease. You take those cells and then you treat each of those cells with different drugs, and you see how do these different drugs have different effects on this disease. And so you can test thousands of FDA-approved drugs to see, do any of these drugs approved for something totally different maybe have an effect on cells for this particular condition. Another approach is the approach that we do a little bit more of in our lab, and that's where you do really, really in-depth profiling of samples from patients with a given disease. So you've heard people talk about genomics and proteomics and transcriptomics. So it's really about doing those sort of studies to really get a good understanding for, what the heck is going on in this disease. And then you say, okay, well, if I understand what's going on here, what drugs are known to either decrease something that's too high or increase something that's too low? It's kind of like saying, okay, figure out what's going on and then figure out what does the opposite of what's going wrong. And then the third approach is to really leverage the fact that there are millions of papers and maybe billions or trillions of data points that have been published over the last several decades about these diseases. And so it's using artificial intelligence and machine learning to find patterns within all these data points to be able to say, is there something in there that a human like myself couldn't find, but maybe a machine can find? And so all three of those approaches have pros and they have cons. And I'm a big proponent of take any of those three approaches to figure out a drug that might work. And then the next step is it safe? And if it is safe, then maybe it could be used safely in a small number of patients with that condition to see, does it seem promising? If it does seem promising, that's when you really need to move forward to really rigorous randomized controlled trials. And I think a big problem with the COVID pandemic thus far is that it's really hard to interpret data from studies if most people who get COVID actually improve. So that means that if we were to give 100 people with COVID, let's say we give them Skittles. We don't think Skittles are probably going to be effective in treating COVID, but we're just going to give 100 people Skittles when they're diagnosed. Over 90 of those patients will actually get better. And you may say, oh my gosh, the Skittles just cured 90% of COVID. And said, well, maybe it wasn't the Skittles. Maybe 90% were just going to get better without any sort of treatment in the first place. So it's really hard if you don't do these randomized controlled trials where you say, okay, I'm going to give, instead of giving 100 people Skittles, I'm going to give 50 of them Skittles, and I'm going to give 50 of them Skittles plus some drug that we think is going to work. And then you can get a sense to people that get the Skittles plus some drug, whether it's tocilizumab or something else. If that group does better than the people who got Skittles alone, then you say, okay, I think it's the drug that's working. It's not just the fact that a lot of people get better with COVID, regardless of what they're treated with.
So basically, you're triangulating information to narrow down all the options.
Exactly. And then at the end of the day, it's also being really humble about realizing that you can triangulate all you want, but at the end of the day, the word you used is right, and that's options. And that's that these are drugs that are candidates. They may be effective, but none of us can say, okay, this drug looks really good in the lab in my test tube. It's definitely going to save lives. It looks really good in my lab. It looks promising. Now let's be humble enough to really do the rigorous clinical trials so that way we can show whether it works or not, and also be prepared to accept if it doesn't work, because we don't want to spend time on drugs that are not going to be effective. We need to move those resources towards other candidates.
Well, it seems to me that the act of repurposing drugs that have already gone through some pretty rigorous trials for other diseases gives you a leg up, because right now, if they're trying to create a brand new one, they have to go through all that and then some before they can then bring it to the public.
That's exactly right. So if you know that it's already approved for something, you know that it was safe enough that the FDA said it's safe enough for approval. So that's great. Right away you're saying, okay, it's safe enough. It's not always perfect, but at least it's safe enough. And then secondly, you know that it does something in that other condition that it's already approved for. And you generally know pretty well how it works. And so now you've got some good information about the drug. Whereas, as you said, if you're starting from scratch, you have to figure out, does it cause lots of harm? I mean, a lot of drugs have gone through clinical trials that have caused harm and actually killed patients. But thankfully, those drugs never got approved. So they got kind of, moved out of the line. But with a new drug, you don't know what it's going to do. You also don't always know exactly what it's going to do when you give it to people. That's why I'm so amazed by my friend Kazuo Yoshizaki that I shared tested that drug on himself, is that you just don't know what it's going to do. And I think that's partly why he tested it on himself. He didn't want the onus, and he was afraid of, if it causes tremendous harm to other people, he would have felt awful about it. I'm not recommending that drug development should involve scientists testing drugs on themselves. I think that's better left to comic books. But I think this is an example where he's just inspirational to me that he was willing to take that sort of a step.
Yeah, beautiful man of service. That is amazing. So we're just about out of time in this segment, but when we pick up on the other side, I'd like to discuss, we're in a big hurry. Are we likely to run the risk of making mistakes because we're under so much pressure and a big hurry, and how to prevent those mistakes? You game?
Sounds good.
All right. But it is time for a quick pause. Dr. Fajgenbaum and I will return to our discussion shortly, so you stay right there. This is Mission Evolution. We're coming to you on the X-Zone Broadcast Network, www.xzbn.net. Welcome back. This is Mission Evolution. Did you know our entire leading edge, information packed past episode collection is available to listen or download with our compliments? Visit our archives at www.missionevolution.org for our ever growing selection of guests and topics. Our guest this hour is Dr. David Fajgenbaum. We're speaking about Castleman's disease, cytokine storms, and COVID-19. His website, chasingmycure.com. Dr. Fajgenbaum, we were just about to go into all the pressure that the scientists are under to find a cure, because let's face it, everything's been shut down. Things aren't going well because we don't have one, a cure or a prevention for COVID-19. So, but does that have us running the risk of making mistakes and pushing through something prematurely that really isn't safe?
It does. I think that many of us that either perform science or that are part of the scientific community or patients, I think that many of us feel like things typically move too slowly, and that I think we're always looking for how can we speed things up. But you're right. Right now, I think the feeling is that it feels like things are maybe moving a little too quickly, which if you asked me, could things move too quickly, I probably would have told you no about a year ago, because I didn't think that there was a too quick. I thought that it was only too slow. But I think you're right. I think we have seen with COVID, there have been some silver linings. Like I said, people sharing data in new ways, collaborating more than ever, repurposing drugs. There's an urgency that I think is healthy and good. But you're right. Sometimes it can become too much of an urgency, and maybe we make mistakes. I think that a number of the trials that have been published typically would have been probably, rather than 2 or 3 weeks after a study's done, we'd be talking maybe 1 to 2 years after the study is done. It would be typically the time frame for when these studies would get published. And during those 1 to 2 years, there would be a lot of people that would look at the data and in many ways to make sure that the results were how we all would interpret them. So we're at risk for sure. And I think that though we're at risk of moving too quickly, we have to find that right balance where we're moving fast enough, but we're also following the really important principles of science. And that's that you're always looking to disprove something that you're looking for. You're not trying to prove that something works. You're trying to disprove, to show that it doesn't work, to really to be rigorous in saying that, my bias is that it won't work. Let's try to make sure to prove that it actually does.
So that's kind of a reverse way of dealing with the observer syndrome, isn't it?
That's right. I mean, there's observer syndrome, there's confirmation bias, where people like myself, researchers, we all want solutions. I mean, we all want drugs to save COVID patients' lives yesterday. None of us want this to take any longer than it has. And so we have to realize that we're biased towards wanting to see something that may not be there. And if it's a drug that we identified in our lab, we're going to have an even stronger confirmation bias, because as hard as we try, we're going to want it to work maybe even more than if it wasn't from our lab. So we have to try even harder to make sure that we're really having a high burden of proof that's required to prove that something actually works or doesn't. And it's tough, because I think we all want things so quickly.
Well, lives are on the line, so it's no wonder we're in a bit of a hurry.
You're right, but I would say, Gwilda, to the reverse of that is that there have always been lives in the line for so many diseases. In fact, you may know these numbers already, but there are over 7,000 rare diseases that affect 30 million Americans, and almost all of them don't have a single approved drug. And so there's always been that urgency. There's always been lives on the line for all of these diseases, but there hasn't always been the urgency. And I think we have to kind of figure out that balance. Why up until COVID have things been moving, relatively slowly, and now with COVID, they're moving at lightning speed. I think it's too fast now, but I think it was too slow before. So we got to find that right middle ground.
Yeah, middle ground is the key. Change gears a little bit. I understand that you're in remission now. Would you mind sharing what your journey was like from almost dying to the active, functional doctor that you are today?
Sure. So as you shared earlier, I went from being this healthy medical student to nearly dying in the intensive care unit. I actually nearly died 3 times over a 6-month period and required chemotherapy to save my life. So when you don't know what to target in the immune system, if you give someone really high dose chemotherapy, it'll actually wipe out the whole immune system. So we did that, and that saved my life multiple times. And then I was actually started on an experimental drug, a drug that was inspired by Kazuo Yoshizaki's research. And I hoped that drug was going to keep me in remission. I was able to go back to medical school. I finished my 3rd year of med school. And then out of nowhere, I relapsed on this drug. So now here I was relapsing on the only drug in development for my disease, and I was completely out of options. My doctor explained to me that there were no more drugs in development. There were no more promising leads. There were no researchers doing promising work. I mean, I was out. I was out of options. And so I turned to my dad and my sisters and my girlfriend at the time, and I promised them that I would dedicate the rest of my life, however long that may be, to trying to find a drug that could save my life and other patients with my disease. And so I set out on this journey. I started a foundation called the Castleman Disease Collaborative Network. I started conducting research in the lab, and I was making progress. But about a year later, I relapsed again, and again I was out of time, and I realized that I just didn't get it done fast enough. As hard as I tried for that year, I didn't do it quick enough because I didn't think I would survive. But thankfully, for the 5th time, I survived one of these deadly episodes thanks to chemotherapy. And now I knew that I was just so fortunate to make it through that. I had to find some drug that could help me, and that's what set me on this path to find the drug sirolimus, where I performed a series of experiments that led me to figure out what seemed to be wrong in my immune system. And then I started searching, well, what drugs already exist that can maybe turn that around, that can either decrease the things that are too high or increase the things that are too low. And I came across this drug sirolimus, and it had never been used for Castleman's, and I was completely out of options. And my girlfriend at the time, Caitlin, and we were engaged to get married, and I so badly wanted to make it to our wedding day of May 24th, 2014. And I really was willing to do anything, and that's when I started testing this drug, sirolimus, on myself. And I never thought that I was going to make it to our wedding day. I just knew I had to try, and I made it to May 24th, 2014, and all of a sudden I made it to May 25th, 2014, and as the time has gone on, it's now been over 6.5 years that I've been in remission. Just so thankful for every moment, and really just felt like I had to share this story and this message of hope with the world. And that's why I wrote Chasing My Cure, because I just feel like I've learned so much about life, so many lessons from this journey about fighting back, hope, resilience, that I just felt like I had to share with the world.
Mm-hmm. I'm sure glad you are. Now, how can a person tell if they are indeed running kind of inflammation in their system as a matter of course, like they're always in a state of inflammation, so that we can kind of start getting a feeling, well, we might be a little higher risk than the guy next to us. How can you tell?
There's one lab test that's pretty good for distinguishing this. It's called C-reactive protein. And basically, C-reactive protein, it's produced by cells in your liver whenever there's any sort of inflammation. So if your body is inflammation, then your liver cells are going to make C-reactive protein. And so if you test the blood and you say, oh, wow, C-reactive protein's up, there is inflammation going on. So it's actually been used for, I'd say, over a decade now, because it turns out earlier on, you hit the nail on the head. You talked about how cardiovascular disease is linked to the immune system. And actually, there are a number of studies that prove that if your CRP is elevated because you have inflammation, you are at increased risk of having a heart attack. And so this is a great example where you test the levels of inflammation, and then if the levels of inflammation are high, you get a sense for, okay, you are at increased risk of a heart attack, or as you know, many other conditions that are also associated with inflammation. So CRP is the best way to measure that.
How about just symptoms that a person, everybody's not going to run out and get a CRP.
Yes, I agree.
or,
I'm not
or we would
recommending
overwhelm
that.
everybody, right?
Yep.
So what are the symptoms, just as, observing ourselves, that we can notice that might indicate, well, we better go get that test?
Yeah, it's a good question, and it's really hard because, things that are symptoms of inflammation are also symptoms of a lot of other things. And so a little bit of low-grade fatigue would be something that would tell you that maybe there's some inflammation. If you can actually see the area of inflammation, you'll see some redness there. But as you know, most of our body is not visible, right? And so if you have inflammation in your body, you probably can't see the redness associated with it. And so it's hard. I think that it's, are you feeling different than you used to feel? And certainly if you're worried that you have COVID, the things that you need to be looking out for are a change in sense of smell or taste, a cough that's often associated with it, certainly fever, shortness of breath. These are the kinds of things that you should really be looking out for. But in the absence of COVID, it's really hard to to really nail down on, like, this is the thing that should get you, looking for more information.
Got it. I understand the Food and Drug Administration just issued an emergency use authorization for convalescent plasma to treat COVID-19. What is convalescent plasma?
Yeah, good question. So plasma, everyone's got plasma. Plasma is basically the watery, proteinaceous part of our blood. So if you take, draw some blood from you, you'll have a bunch of red blood cells. That's what makes it look red. You'll have a bunch of white blood cells in there. That's what protects you. That's your immune system. And then the rest of the stuff in your blood is a combination of water and proteins and a bunch of other molecules that are in. So that's your plasma. It's the stuff in your blood minus the cells. And so now probably one of the most important aspects of your plasma are all of the antibodies that are built up in your plasma. So your body, when you encounter a virus, you'll start making antibodies against that virus, and that's why you'll eventually control and kill the virus, and you'll eventually have immunity against it when you encounter it again in the future. That's the concept of immunity due to antibodies. Now, if you've encountered COVID, you have undoubtedly made antibodies against the COVID virus, because if it's convalescent, means that you're better, you're now feeling better. So you were sick with COVID, you're in a convalescent, you're feeling better state, which means that the virus SARS-CoV-2 was controlled, and now you should have high levels of antibodies. So the idea is that now you take plasma from someone who just fought off COVID, which has all of their antibodies in it, and you give it to someone new, and now they have antibodies against COVID, which is awesome, because that's going to help them to fight the virus. However, it's a lot more complicated than just that. And that's because your antibodies only last in your blood for a certain period of time. So if you get antibodies from someone else, those antibodies are only going to help in the short term, maybe in the next few days to weeks. So it's not like we could just give antibodies and convalescent plasma to everyone, and that's going to prevent us from getting sick. You have to keep giving it to people if you want to use it in a preventive state, but you definitely need to give it to folks in the midst of active disease to expect that it would work. However, what's also become clear is, as you mentioned at the beginning of the show, there are people that actually are fighting the virus pretty well, but it's their immune system that causes all kinds of other problems that lead to them dying. So that person who's really sick in ICU with COVID, they may actually already have plenty antibodies against SARS-CoV-2. The problem isn't that they didn't have antibodies. The problem is that their immune system is out of control. And so the convalescent plasma likely wouldn't be effective for those people.
And do they have a way of knowing if it's going to be effective or not?
Right now there's some okay data to suggest that if you get your antibody levels, if let's say you've newly been infected with COVID and you get your antibody levels tested for COVID and you find out that you've got low antibody levels, those people are more likely to benefit from getting convalescent plasma from someone else who has high antibody levels. Because if you give someone who's got low antibodies to someone with low antibodies, it's not much of an effect. And if you give it, if you have someone who already has high antibody levels, then giving them more antibodies is probably not going to be effective. But if you take someone who's newly infected with COVID, they've got low antibody levels against it, and then you take blood from someone who's got high antibody levels and you give it to them, those are the people who seem most likely to benefit. And that was shown in a kind of a sub-analysis of a sub-analysis, which led to that emergency compassionate use or emergency approval. But more work is going to be needed to really prove that out.
Well, it strikes me, and we're about out of time for this segment, but it strikes me it's very similar to a nursing mother passing on her antibodies. But like 2 days after she quits nursing, the child can come down with all of that stuff.
Exactly. That's a really good analogy. I need to start using that.
You're welcome to it. It is time for that commercial break. Dr. Fajgenbaum and I will be back shortly to continue our discussion, so don't go away. This is Mission Evolution on the X-Zone Broadcast Network, www.xzbn.net. Welcome back. This is Mission Evolution, bringing together gifted people of service to the world. I love to hear from our audience. Your thoughts are very important to me. To suggest a topic or guest that you think would be of interest, email us at info@missionevolution.org. And speaking of gifted people of service to the world, this hour we're sharing thoughts with Dr. David Fajgenbaum. His website, chasingmycure.com. David, we were talking about all the different ways that, that plasma might help, but it really doesn't. That, it's never so simple, is it? Everybody is so different that, and we're really seeing this with COVID, is everybody is so different and their responses are so different and their history is so different that one thing might work and one thing might not. How are we going to weed our way through this to find a way of treatment?
Yeah, you're absolutely right. I think that all of us want it to be simple, and there's one drug that works for everyone, and that would be amazing. But thus far, it hasn't seemed to be that simple. And so I think that we need to keep doing these trials. We need to keep getting a sense for who does it work in, who doesn't it work in, who does it work in, and then really get to where we can do tests on people before we give them a drug, and we can say, okay, based on the result of this test, you're more or less likely to benefit from this drug. And ideally, we'll get to a stage where there's many drugs that are effective, likely at different stages of COVID. So we've already seen with the drug called dexamethasone, which is a corticosteroid, that it's really, really effective if you give it to people who are quite sick. So if you give it to someone who's in the ICU or they're very sick in the hospital, there's a major reduction in mortality in those people. But if you give the same drug to people who are not yet in the ICU, who are not yet receiving oxygen therapy, it's actually harmful for them. There's a worse overall outcome for people who are in their early stages. And that just highlights that not only does it seem to be complicated on a patient-to-patient basis, like you said, some people get better with this, some people get better than that. This is even within the same patient, depending on the timing that you give the drug within that same patient, you're going to have different responses. And so it just highlights that this is a complicated disease, and we're going to need to continue to understand, okay, this drug may not work for these people, but maybe it works for those people, and we really need to nail down the right drugs for each of those people.
It's I was wondering, is indeed this one of the most complex diseases we've been confronted with lately?
I think that I would say it's definitely up there as one of the most complex diseases. I think that part of what's so difficult about it is that we want answers so quickly. So there is an incredible amount of work being done, but there's still so many unknowns. I mean, I think that for diseases that have been around for a long time that are really complex, I mean, I think that we would all agree that HIV is very complex. That's why there's no vaccine, even though we've been working on vaccines for decades. So it's a very complex virus, but SARS-CoV-2 is complex in so many ways. As you mentioned earlier, there's all these people who have asymptomatic infections. I mean, some people, they don't even know that they got SARS-CoV-2, and other people, they're dying in the intensive care unit. And that really is kind of mind-boggling, isn't it?
It is. And I think it also adds to the confusion that the masses are suffering from right now because, there's a lot of misinformation out there of,
Hmm.
oh, it's all, conspiracy theories and everything else. But I think that this uncertainty and this mixed bag of responses that we're getting from different people is really playing into that, don't you?
Oh, I totally agree with you. I think that if everyone uniformly had the exact same response, then that would mean that everyone's friend would have had a similar experience, or everyone's aunt or uncle who's had COVID would have a similar, and we would all be on the same page. But you're right, some people are having really bad, and the people who are having really bad responses, their family members are terrified of COVID. And then the people where they're having, a mild or asymptomatic case, their family members are like, hey, what's all the fuss about? And I think that we were talking earlier about the whole confirmation bias. I think that, what we've seen in one case now becomes all the cases we've ever seen. And that informs how we think about this virus, when we really should recognize that there have been 2 million deaths around the world from this virus. And there have been many more people who've gotten it and have not died. And so, I think humility is an important characteristic in saying that we just don't know, and we can't really rush to judgment one way or another yet.
How much does the go back to anxiety and fear? How much does that make us more susceptible to having a worse case of it?
I think that there's two things with anxiety. So, anxiety is never a good thing. It's always better for us to be in a good state of mental health. However, if being anxious about the virus means that you're going to follow precautions like social distancing and mask wearing and hand washing, then it may be that anxiety is what saves your life. At the same time, being anxious and having anxiety is not a good thing, and it's not something that I would recommend, or that I'm saying people should be anxious. I'm not saying that at all, but I think it's about finding that balance where you respect viruses like this and you recognize that it is a slot machine. We don't know how any one of us is going to respond to this virus. We may have good data to suggest that some of us are going to do better than others, but it's about being humble, that we don't really know, but it's also about having a healthy dose of awareness, maybe not anxiousness, but awareness, that we need to be careful.
Well, when you go into anxiety, you go into the back brain and you're in fight or flight. There's no
Hmm.
logic or decision making there.
Hmm.
It's just knee-jerk reactions versus, like you're recommending, recognize the potential and take the logical choices. And I, how can we find that balance between not responding at all or going into fight or flight versus just being logical and taking the logical steps?
I don't know the right answer. I think that I've always thought education is the way to get to that, but I've realized throughout this pandemic that I still think education is so important. But I've realized during the pandemic that two people can hear the exact same words and come up with totally different interpretations. And I guess I've always known that, but it's hard because there are sometimes very clear messages that are misunderstood, and sometimes there are very unclear messages that seem to be better understood. So I think it's really tough, but we as a society need to recognize that we don't know everything, and we need to be humble enough to realize we don't know everything, but also recognize that more work needs to be done, and that to try our best to follow recommendations that are made, but also kind of cut those people making recommendations slack, and realizing that they're not going to be right 100% of the time. But we're all just doing the best we can.
Boy, isn't that the truth? We're all doing the best that we can in a very difficult situation.
Hmm.
How do you see the challenges of these times impacting the future of medicine?
I see them. There's a few that I'm certain are going to affect medicine. One is telemedicine. I think that moving forward, there are going to be a lot more capabilities to see your doctor from the comfort of your own home. We've proven we can do it, because many hospitals ramped up telemedicine really quickly. I think that we also are going to see a lot more data sharing and collaboration, because, again, we've proven that researchers can share data. We just need to have the right structures and the right urgency in place. And I think that the third piece is around drug repurposing, that we really We've shown that we can really quickly mobilize drugs that were developed 50 years ago for something else and to show whether they work for COVID or not. Why aren't we doing that for all the other conditions that are waiting for solutions? And so I think that there's going to be some positives. There obviously are way more negatives, the lives lost, the anxiety you mentioned, the suffering that people have gone through, the grief that people are going through, grieving the loss of a loved one when you couldn't be with them their final days. I mean, that's just heartbreaking. From my experiences, when I've spent months now hospitalized in intensive care units, and I frankly don't think I would have survived if I didn't have my dad, my sisters, and Caitlin by my side. So I can't imagine what it's like to go through an illness like this, a cytokine storm like this, and to not have the people you love by your side. It's just devastating. But all I can hope is that some positives, some silver linings will come from this, so that we can, help people moving forward.
I think that we're grieving so much. I mean, even those of us that haven't lost somebody to COVID, we're grieving our whole way of life because everybody says, "Oh, let's get back to normal. I can't wait till we get back to normal." This is a game changer, don't you think?
Oh yeah, I think we wish so badly everything would return to normal, but I think you're right. I think it's a game changer in that it's just going to really change how we live, and maybe there is a time when we get back to normal 5 or 10 years from now. Who knows? And when I say get back to normal, I don't mean it's going to be 5 to 10 years before we're back to a semblance of normalcy. But I'm just saying, like, to get totally back to the way things were, it could be a really long time, and we're all hopeful that in the short term, we'll start getting closer and closer to the pre-COVID normal.
But also, we're just about out of time for our time together, and I don't want to end on a negative note, but I think we're just starting to see the ramifications long term on patients from COVID. There's long-term ramifications. Is that accurate?
Yeah, there's this new syndrome that all of us are talking about called the COVID long haulers. And so these are people who they got infected with COVID, they were sick with COVID, and then they got better. But for some reason, their symptoms never fully went away. And now 3 months later, they're still in a brain fog, or they're having joint pain, or they're just feeling unwell months later. And so that's something I really worry about, is this kind of long-term, long hauler syndrome, and what it's going to do to people. So let's all hope that it's not going to be as bad as many of us fear. And I think that, listeners should feel comfort knowing that there is so much work being done in the medical field. I mean, there are colleagues of mine who are cardiovascular disease researchers who had never, ever studied the immune system before, that have turned their time, their effort, their energy, their intelligence at fighting COVID. And so my lab, where we've been studying related cytokine storm disorders, we're full speed ahead after COVID. So I hope listeners know that there is an incredible large group of people that are working really hard on COVID, and we're doing everything we can, and we're already seeing the fruits of that labor. There are drugs that are already being revealed to be effective. There are more coming down the pipeline, and we're just going to keep doing everything we can to keep chasing cures for COVID.
Oh, we're so grateful you guys are out there in the trenches. You're the ones that are going to find the solution to that part of it. That's a fact.
Well, thanks for helping to elevate the work that we're doing and helping to spread the word about the work we're doing, and also about my journey chasing my cure.
What a beautiful story it is. In closing, would you like to share with Mission Evolution's worldwide audience what will help us evolve through this crisis?
I think it's around the number one thing I would say is that we need to turn our hope into action. And when I say that, that's the subtitle of my book, because many of us hope for a lot of things in our day. We hope for health and well-being and prosperity. And many of us take action to get us closer to that which we're hoping for. But sometimes with things like COVID, we can feel like it's totally out of our control. And so I may be hoping that COVID ends soon and that it doesn't have a big impact, but I'm not actually going to do anything about it. And I think all of us should realize that we have the power to social distance, to hand wash, to put on a mask, to do the things that we can to take action, so that thing that we're hoping for, which is that COVID will be out of here soon, will be closer to reality. And I think that it's bigger than COVID. I think for your listeners, it's about turning hope into action and saying, if I'm hoping for something, what can I do to make that hope a reality?
Isn't that a beautiful message? Because it seems like we feel so victimized by this, we just sit on our hands and worry.
That's
And
right.
yet, I'm not a medical person, but I can do my part in doing what I do with my show to share the message. You are
That's
a
exactly
medical
right.
person and you're in the trenches working it. But each of us has an option to be part of the solution rather than part of the problem.
I totally agree.
Well, I'm sorry we are out of time. I could go on and on with you. Dr. Fajgenbaum, thank you so much for coming on the show.
Thanks so much for having me, Gwilda.
It's been a real pleasure. Our guest this hour has been the author of Chasing My Cure, A Doctor's Race to Turn Hope into Action, Dr. David Fajgenbaum. Labeled the doctor who cured himself by New York Times, Dr. Fajgenbaum is a groundbreaking physician, scientist, disease hunter, speaker, and best-selling author. His website, where you can find out more about him, is chasingmycure.com. Remember, our entire information-packed past episode collection is available for listen or download free of charge. Visit our archives at www.missionevolution.org for our ever-growing selection of guests and topics. This has been Mission Evolution with Gwilda Wiyaka on the X-Zone Broadcast Network, www.xzbn.net. Join us next time as this mission continues, bringing you information, resources, and support to a tumultuously evolving world.